Hi everyone, Assalamualaikum. In this video, we will continue with example 5 under linear equation for first order ODE. Solve the differential equation dy over dx plus y z squared x equals to 2 z squared x given y equals to 4 when x equals to 0. From the given question here, we have term containing y to the power of 1. And there is no term containing y for the other term. So this is linear equation. To solve linear equation, first step, we need to write into the form of dy over dx plus pxy equals to qx. And please note that the coefficient of dy over dx should be equals to positive 1. Right? From the given question here, we already have coefficient of dy over dx equals to positive 1. Okay, so we need to rearrange this equation into the form of dy over dx plus pxy equals to qx. Right? So from here, we have dy over dx plus in bracket z squared x and then times y equals to 2 z squared x. Right? From here, now we can compare with the standard form of linear equation, right? And then we continue with step 2. Identify Px and Qx. Right, from here, we have dy over dx, where coefficient of dy over dx equals to positive 1. And then we have plus sign here, and then beside term containing y, we have px, right? Px equals to z squared x. Qx equals to 2z squared x, right? Qx should be the term not containing y, right? And after that, we continue with step 3. Find integration of px dx. Integration of px dx equals to, we replace px equals to z squared x, right? And then from integration formula, integration of z squared x dx equals to tangent x plus c. Okay, but we don't need to write plus c because we still not finish our solution, right? Then we continue with step 4. Find integrating factor, IF. The formula is e to the power of integration of px dx. Right, from here we have IF equals to e to the power of tangent x. Okay, we compare from here, integration of px dx equals to tangent x. So we substitute here. We have e here and then to the power of integration of px dx, and we replace integration of px dx equals to tangent x, right? And after that, we continue with step 5. The solution is y times if equals to integration of qx times if dx. Right, so we have y times e to the power of tangent x equals to integration of 2z squared x times e to the power of tangent x dx. Right, from here, we replace if equals to e to the power of tangent x. We replace qx equals to 2z squared x. And we replace if equals to e to the power of tangent x dx. Right? Then we rearrange. Okay, so we have y e to the power of tangent x equals to, we can move out constant 2 from integration sign. Right? Remember, we can move out constant from integration sign. but never move out variable from integration sign. Right? Then we have 2 integration of e to the power of tangent x sec squared x dx. Right? From the previous slide, we get ye to the power of tangent x equals to 2 integration of e to the power of tangent x sec squared x dx. Alright, we no need to integrate the function on the left hand side because there is no integration sign. But we need to integrate e to the power of tangent x sec squared x dx because we have integration sign here. Okay, to integrate this function, we can use u substitution. Alright, we choose u equals to tangent x. Then, when we use u substitution, we need to differentiate. We differentiate u with respect to x, so we get du over dx equals to, we differentiate tangent x equals to sec squared x. And after that, we need to write dx as a subject. So we just cross multiply, so we get dx equals to du over sec squared x. After that, we substitute back into this function. Okay, so we have ye to the power of tangent x equals to 2 integration of, we replace tangent x equals to u. And then we still have sec squared x and then times, we replace dx equals to du over sec squared x. Right? And if we choose the correct method and the correct u, we can simplify all terms containing x. So in this case, we can simplify sec squared x here and sec squared in denominator here. Right? And after that, we have ye to the power of tangent x equals to 2 e to the power of u du. Okay? And then, we can integrate e to the power of u du using this formula. If we integrate e to the power of x dx, we get e to the power of x plus c. So now we integrate e to the power of u du. So the answer equals to eu plus c. Right? After that, we replace u equals to tangent x. So we get this. Okay? Then we can write y as a subject. Normally for linear equation, we write y as a subject. So when we write y as a subject, we move e to the power of tangent x to right hand side. When we move e to the power of tangent x to right hand side, means we need to divide each term on the right hand side by e to the power of tangent x. So we have y equals to, we divide 2e to the power of tangent x over e to the power of tangent x. So we get 2 here and then plus c over e to the power of tangent x. But we can write using the properties of indices, we move up. Okay, so we get c e to the power of negative tangent x. Alright. This is our general solution. Okay. Alright. But from the given question here, we have initial condition. Means we need to find the value of c. Okay. To find the value of c, we need to applying the given initial condition. So for this equation, we can name as equation 1 so that it's easy to refer. Right? Right. We continue with step 6. Okay. If the initial condition is not given, this is our final answer. This is called the general solution. Okay. But now, the initial condition is given. So, we need to continue with step 6 to find the value of c. Right? So, step 6, applying the given initial condition to find the value of c after we integrate. Right? So, we need to substitute the initial condition x equals to 0 and y equals to 4 into equation 1. Right? So, we have y equals to 4. So, we substitute here. Y equals to 4 equals to 2 plus c. And then we replace x equals to 0 here. Tangent 0 equals to 0. Okay? So, we have e to the power of 0. We no need to put negative because 0 is not positive or negative. Okay, we just put 0 here. Okay. And then e to the power of 0 equals to 1. Okay. So we get c here. We move 2 to left hand side here. So we get c equals to 2. Right? 4 minus 2 equals to 2. Okay. After we find the value of c, we need to substitute back into equation 1. Okay. Into the general solution. So the particular solution is y equals to 2 plus 2e to the power of negative tangent x. Okay, this is the final answer. Okay, we replace c equals to 0 into equation 1 here. Okay, so we get 2 here. Okay, that's why the final answer is y equals to 2 plus 2e to the power of negative tangent x. Right? This is the particular solution and this is the general solution. Okay. Coming up next, applications of first order ODE. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.